All right, so today I'm going to show you a technique that is called the square root method. So we're going to solve today, but I'm not going to use any factoring techniques this time. This time we are going to learn how to solve, I call them simple quadratics, using the square root method. Okay, so before I talk about simple quadratics, I need to talk about perfect squares because we're going to have to square root today, which means that I need to address perfect squares. Now, you already know what perfect squares are. You saw them in middle school. You handled square rooting in Math 1, and now we're doing it in Math 2 again. So a perfect square happens when you multiply a number by itself. That is how you create a perfect square. So 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. So I'm multiplying a number by itself, and that creates a perfect square. 9 is a perfect square because 3 times 3 is 9. 16 is a perfect square because 4 times 4 is 16. 25 is a perfect square because 5 times 5 is 25. What's the next one? 36 is a perfect square because 6 times 6 is 36. 49 is a perfect square because 7 times 7 is 49. 64 is a perfect square because 8 times 8 is 64. 81 is a perfect square because 9 times 9 is 81. 100 is a perfect square because 10 times 10 is 100. 121 is a perfect square because 11 times 11 is 121. 144 is a perfect square because 12 times 12 is equal to 144. Now, this is what most kiddos have memorized, is all the way up to 144, 12 times 12. I know that there are some of you out there who know, like, have memorized 13 times 13. Some of you go all the way up to like 15 times 15. I've even had students in the past that know all the way up to 20 times 20. Okay, but this is general knowledge here. If you know your perfect squares all the way to 144, you are going to be in really good shape, okay? So now that we know our perfect squares, now we can undo our perfect squares with square roots. So the inverse of squaring a number is square rooting a number. So inverses, like when you can undo addition with subtraction, you can undo multiplication with division, you can undo a square by square rooting. So a square and a square root are going to knock each other out. And the symbol that we use is called a radical. And that's just the square root symbol. It's called a radical. That's what mathematicians call it. So we're going to find the square root of each number below, and then we're going to use our calculator. Okay, you can do it on Desmos as well, to round to the nearest tenth if necessary. And then you're going to label it as rational or irrational. So square root of 16. In my head, I think, what times what is 16? 4 times 4 is 16. So that means that the square root of 16 is 4. Watch. Square root 16, boom, 4. 4 is a perfectly normal number. So is it rational or irrational? Perfectly normal means it is a rational number. Square root 12. In my head, I'm thinking, what times what is 12? Like 3 times 4, but that's not the same thing times the same thing. I can't think and look at 12. Oh, wait, right here. 12 is not in my list of perfect squares. Well, if it's not in the list of perfect squares, it's not going to happen perfectly, which means I need to punch it into my calculator. So rounding to the nearest tenth, this is going to be approximately 3.46. So the 6 tells me to round to a 5. Now, this number is going to go on forever and ever and ever and ever and ever. That's crazy, right? It's so crazy that we call it an irrational number. 24, is that a perfect square? 25 is, 16 is, but not 24. Dang it. So it's not perfect, so we're going to have to use our calculator. So the square root of 24, that's going to be approximately 4.89. That 9 tells us to go to 4.9. This number goes on forever and ever and ever. It is insane. It is irrational. 100. Is that a perfect square? Sure is. It's 10 times 10. So that means that the square root of 100 is just 10. It's perfect. Gives me a perfect number. That is totally rational. 400. I don't know. My list only goes to 144. I don't know about 400. Well, maybe it'll work out nicely. Maybe it won't. So square root 400. Oh, that means it was a perfect square because it worked out perfectly. Square root of 400 is just 20, and that is totally rational. Oh, one thing I want to point out to you is if you don't have a calculator and you are not around a computer to have Desmos, you know, your calculator on your phone, I'm going to it right now, your calculator on your phone, if you turn it sideways, it becomes a scientific calculator, and you have more functions if you turn it sideways. So if I wanted to do the square root, it looks a little different, but that's the square root button. The square root of 400, that's giving me an answer of 20. So your phone can do simple things like square rooting a number. And all you have to do is go into your calculator and turn your phone sideways, and then that happens. Okay, 500. Yeah, I don't have my perfect squares memorized that high, so let's give it a whirl again. So the square root of 500, bummer. 22.36, the 6 tells me to make that a 4. So 22.4 is my approximation, and this is crazy forever infinitely long number. That is irrational. So on these numbers where there are no perfect squares, what happens is we end up getting a decimal answer, okay? But decimals are rounded, they are not exact. And in mathematics, we want exact answers. So a square root is simplified when there's no more perfect squares left over. So I'm going to show you a process how you can simplify by bringing out your perfect square numbers. All right, we are simplifying, which means that your original and your simplified radical have to be equal to each other. Okay, we're going to check it in our calculator, but it has to be equal to each other. So this is what I'm going to do. I am going to use a factor tree in order to break this number 20 down. So a factor tree, factor means multiplication. So what numbers can I multiply to get 20? Well, I could do a 2 times a 10. I can break down 10 again. How do I get to 10? Well, that would be a 2 times a 5. Now, how do you know when you're done making a factor tree? Well, you're done making a factor tree when you get to prime numbers. Prime numbers means that it's only divisible or multiplication by 1 and itself. So 1 is a prime number. 2, because 2 times 1. 3 would be 3 times 1. Let's see, 5. 6 is a no because that's 2 times 3. 7 would be 1. 8 is 2 times 4, so that's not it. 9 is 3 times 3, that's not it. 10 could be 2 times 5. Ooh, 11 is only 11 times 1. 12, nope. 13, yes. 14, nope. 15, nope. 16, nope. How about 17? Can you think of anything times something as 17? Nope, just 17 in itself, and so on. So anytime I get down to these prime numbers that I can't factor any further because it would just be a 1 in itself again, that's how I know I'm done with my factor tree. So this is what it looks like. Your pair that you have comes out of the square root. The non-pair gets left behind. So it's like jail. You can only break out of jail if you have a friend, you know, like they can give you a boost over the wall and then you can like reach over and grab them by the back of the pants and pull them over the wall. The only way that you can get out of this square root jail is if you have a pair and you guys are going together. Anybody who's just by himself isn't going to be able to break out of jail and they get left behind. So 2 square root of 5 is your simplified answer. Now, I know students who like to cross off the number after they've factored it, so their eyes are only going to the ends of the tree. Okay, not inside, okay, just the prime numbers, just the ends of the tree. Now, I want to show you that the square root of 20 and 2 square root 5 are actually the same thing, and I'm going to show you on my calculator. So the square root of 20 and 2 times the square root of 5, they have the same decimal. That means that they have the same value. They are equal to each other. And that's good news because that means that I simplified correctly. All right, let's try 45. So let's see, 45. That could be 5 times 9. 5 is a prime number, so that one's done. 9 can be 3 times 3. And I'm going to cross off that 9 so I don't look at it anymore. All right, 3s are both prime numbers. So do you see the pair that's escaping from jail? Who gets left behind? Oh man, 5 didn't have anybody to escape with. So that means that this 5 has to stay behind. It has to stay underneath the square root. That is your simplified answer. So square root 45, and let me check it, 3 square root 5. Yep, they have the same decimal, so that means that they are the same. All right, let's see, 108. All right, 108. Well, it's an even number, and even numbers are divisible by 2. So 108 divided by 2, that's going to be 54. 54 is another even number, which is divisible by 2, and that's going to be 2 times 27. Now I'm done with 54. All right, 2's prime. How about 27? 27 is 3 times 9. So cross off the 27, we are done with that. 3 is a prime number, it's done. How about 9? 9, we can go again, 3 times 3, and now I'm crossing off 9, and 3s are dead ends. Okay, are you looking for your pairs? Do you see how you have a pair of 2s that get to escape? Do you see how you have a pair of 3s that also get to escape? All right, this is 23? Nah. What operation is going between those two numbers that just escaped? This is a factor tree, and factoring means multiplication. So I had a 2 that came out. I had a 3 that came out. Those are going to get multiplied. Is there anybody left behind? Oh man, this 3 didn't have a pair. Those two went together and left this guy behind. So that means square root 3. So final answer, I multiply my 2 times 3, and that's going to give me 6, and then square root 3. So if two numbers are on the outside, they can get multiplied. If you have numbers on the inside, they can get multiplied, but outside has to stay outside and inside has to stay inside. That is my final answer. So square root 108. And then I'm checking my 6 square root 3, and they are the same. All right, your turn. It literally says it, your turn. Pause me, work them out, and then play and see how you did. 18. I have 2 times 9. If you did 3 times 6, it's going to be perfect. It's all going to work out. 9 is 3 times 3. So I've got a pair of 3s that make it out. Oh man, that 2, you got left behind. Final answer. 60. 6 times 10. 6, I can go again. That's going to be 3 times 2. So I can get rid of that. 10, I can go again. That's going to be 2 times 5. So now I'm done with 10. 3, 2, 2, 5. Those are all prime numbers. Here we go. So I've got this pair of 2s that comes out. Oh man, 3 didn't have a partner. Oh man, 5 didn't have a partner either. What do you think happened between those two numbers that were left in jail? They get multiplied. Final answer, 2 square root 15. And if you checked yourself, square root of 60 and then 2 square root 15, boom, same decimal, same answer. All right, 208. Divisible by 2, which would be 104. 104 is divisible by 2, and that would be 52. 52 is even divisible by 2. I should be crossing those off. Let's see, 26 times 2 is 52. 26 is even, so that would be 2 times 13. All these 2's are done. 13 is a prime number, so my factor tree is done. Check it out. This pair of 2's, they help each other out. I've got another pair of 2's that help each other out. What do I do here? Multiply. Only guy left behind is a square root of 13. So final answer, 2 times 2, that's 4 square root 13. That is how we simplify square roots. Number 4, it says create an example of a square root that is in simplest form. That means that you cannot simplify it anymore. How about this one? Square root 3. Can I break 3 down anymore? That'd be 3 times 1. So it's prime. That means it is totally done. You can't simplify a prime number. How about square root 5? Same reason, right? 5 is a prime number. Let me give you another example. 15. You're like, wait a minute, no. 15 can be simplified. 15 is 3 times 5. Why? Yes, it is. But does 3 have a pair to escape with? No. Does 5 have a pair to escape with? No. There are no pairs which means you can't do anything. It is already simplified. Let me give you another example. 21. There's no way that 21 can't be simplified more. Well, 21 is only 3 times 7. Guess what? Prime numbers, no pairs. That means that you can't simplify square root 21 anymore. It's already simplified. All right, hopefully you have the point. Now let's use it. Now let's use it to solve. What do I mean when I say solve? What am I looking for? I'm looking for x equals. What are the 4 words that let you know that you are solving? Do you remember them? Solution, zeros, x-intercepts, and trees, roots. How about if I write that down enough, then it will be okay. All right, so at the very beginning here, before we were doing all that square root business, I said we're going to learn how to use, or sorry, to solve simple quadratics. They are called simple quadratics because they only have an x squared, and they are missing the x. So in my trinomial, if I have my ax squared plus bx plus c, okay, when we see this, we do the x. If that c is missing and they have something in common, we do a greatest common factor. But in this case, the x is missing, and all we have is this x squared guy and just a regular old number. That would be a simple quadratic. When we have 2 versions of x here, that makes it more complicated, all right? When that x is gone and we just have the x squared, then that is what makes it simple. When we're solving quadratic equations that only have an x squared, then we can use their square rooting method. This is not factoring, guys. We are not factoring here. Most of your answers are going to be in radical form. So this is the only time that we do not use the golden rule. No golden rule. I am not factoring, which means there is no golden rule. We are not factoring here. Oh man, if we're not making it equal 0, then what are we going to do? Well, we're going to do what we normally do when we try to solve something. You are going to use inverse operations to isolate the x squared. That means you're going to get it by itself. Once you have the x squared by itself, you are going to take the square root of both sides, and that is going to give you a plus or minus answer. Okay, I'll go over that in more detail, but that is going to give you this symbol plus or minus. And then, if you can, you are going to simplify the square root. All right, this is simple because it only has an x squared. So we're going to get the x squared by itself. How do I do that? Well, I'm going to start by adding 12 on both sides. And if you like, set up your equals wall. So that's going to be 2x squared equal to 12. How do I get rid of multiplying by 2? Divide by 2. 12 divided by 2 is 6. All right, now the x squared is by itself. How do we kill off an x squared? We are going to square root it. Because the square and the square root are inverses of each other, they knock each other out and leave us with an x. This is going to give me a plus or minus square root of 6. And if I can simplify, I will. 6 can only be 2 times 3. 2 times 3 means there is no pairs. So ladies and gentlemen, this symbol means that you have 2 answers. You have the positive square root of 6, and you have the negative square root 6. So when you see a plus or minus, they're telling you that there's 2 answers there. There's the positive answer and there's the negative answer. You're thinking, oh my gosh, how do I check that? Well, if you are on Desmos or you have your calculator, it's easy. Check it out. 2 parentheses, square root 6, close your parentheses and square it, minus 12. That should equal 0. Yep. All right, now I'm going to do the negative 6. So 2 parentheses negative square root 6, square it, and then minus 12, get you 0. Both of those are correct answers. Okay, so a little bit different technique here. It feels more like, you know, in the past when we were solving linear equations and we were getting x by itself, here we're trying to get the x squared by itself. All right, look at this. This is simple because there's only that x squared. So I'm going to add 9 on both sides. So that's going to be 2x squared equal to 64. And then dividing by 2 on both sides. So I get an x squared equal to 32. Now that my x squared is by itself, how do we kill off a squared? We kill off squared with square root on both sides. So square and square root knock each other out, so that's x. Don't forget, you're always going to forget, I even forget sometimes, plus or minus the square root of 32. And then if I can simplify, I'm going to simplify. Can we simplify square root 32? Well, let's try it. 32 is 2 times 16. 16 is 4 times 4. 4 is 2 times 2, and that 4 is 2 times 2. So I think we're going to be able to simplify here because we have many pairs. So I've got a pair of 2's right here. That comes out. I've got another pair of 2's here. That comes out. And then I have this 2 left by itself. So that one stays behind. So I'm multiplying here, and I've got my plus or minus answer. So I'm going to put my final answer right here. I'm going to have a positive and a negative version. So 2 times 2 is 4. So I'm going to have a positive 4 square root 2, and I'm going to have a negative 4 square root 2. That negative is on the outside in front of the square root, okay, in front of the number there in front of the square root. So you can plug that here into your calculator and check your answers. Try this one on your own. Pause me, play it. So did you subtract 3 on both sides? That's 108. And then did you, I'm sorry, not subtract, did you divide by 9 on both sides? Which gets you 12. All right, now what? I've got an x squared. How do I get rid of an x squared? Square root it. Square and square root are gonna knock each other out, and that's x. Don't forget, plus or minus the square root of 12. I'm done, or maybe I'm not. Can I simplify the square root of 12? Well, let's check. 3 times 4, And then 4 is 2 times 2. So yes, we have a pair. So I'm going to have plus or minus. 2 comes out. I've got that 3 left behind. So my 2 answers are going to be a positive 2 square root 3 and a negative 2 square root of 3. So 2 solutions here. One is the positive version, one is the negative version. All right, last one. Give this one a try on your own as well. Pause it and move forward. Did you subtract 10? And then did you divide by 5? And then did you kill off your square with a square root? Did you remember your plus or minus? Did you try to simplify? No. 6 times 10. Ooh, 6 is 2 times 3. That's done. 10 is 2 times 5. That's done. Did you see your pair of 2s? So plus or minus 2. I've got a 3 and I've got a 5 that gets stuck behind. So that means I have to do a 3 times 5. So final answers. I'm going to have a positive 2 square root 15 and a negative 2 square root of 15. Those are your 2 final answers. So ladies and gentlemen, please be doing your simplification, okay? Make sure that you are practicing that. You are going to be taking a multiple choice final exam, and sometimes the answers, they are writing them as decimals to you, but sometimes they are writing the answers as square roots or radicals, okay? Your practice, I'm looking for your practice. Oh, your practice is right here. So your practice says that you need to do the square root method, and it says simplify your final answers if needed. So that means that you are going to have square roots in your final answers, just like we did right here. All right, practice simplifying any numbers that you can simplify. All right, that's it for now. I will see you soon.